Hey everyone, thanks for having me. Today I'll be talking about the technical part about the Therapeutics Actionability AI challenge. So I'm Cyril, part of the health lead at Hugging Face, health team at Hugging Face. I think we're going to skip that part. All right, so here's an overview of what I'll talk about today. So what is Hugging Face, models and datasets, Gradio, spaces, and then retrieval augmented generation, model context protocol, AI agents, and finally constraint generation. Now that seems like a lot of technical jargon. I know this is supposed to be a chill conference, so I'm going to keep it pretty superficial. Feel free to find me after this conference for more information. Let's begin. So what is Hugging Face? Well, it's a difficult question to answer. I can't even tell you. But what I do know is we're the AI backbone of the current AI movement. We kind of operate at the model level, at the dataset level, at the deployment level, and even at the educational level. So we host around 1.6 million models across various tasks and across different fields on the hub, which you can easily download using a single or two lines of code. You can access about 400,000 datasets for training and evaluation, and these datasets are uploaded by different companies, institutions, healthcare, hospitals, etc. If you're interested in deploying these models or even using these datasets, we offer single-click deployments, and these are production level. And if you want to learn more about AI, we offer courses and certifications which are entirely free. So let's talk about models. So if you navigate to our model spaces, you'll see that we have a lot of, like I said, millions of models. Currently, you can see the current trending ones are Qwen and DeepSeek from our friends in China. You can filter them by the task that they solve, the different fields, so computer vision, NLP, etc. And these are models that you can use to tackle the Therapeutics AI challenge using, again, one or two lines of code. Similarly, we have a lot of data sets that are uploaded by our friends at different companies, including Anthropic, OpenAI, Stanford, etc. These are, as you'll see, you can use these data sets inside of your RAG pipeline, which I'll talk about in a few minutes. And you can filter them by the task, by the size of the data set, and more. Space is a way for you to use these models and data sets in a self-contained space that you can then embed on your website, deploy to your friends, family, kind of show them your cool little AI project, and even use with an AI agent, which I'll talk about in a few minutes as well. Here you have a few trending models as well. And finally, Gradio is our solution to building the UI for these AI models. So instead of having you learn JavaScript, TypeScript, whatever it is, Swift, to deploy a user interface for your AI model, we give you the building blocks and just have you learn Python, which I think everyone should know, but that's an aside. All right, so let's talk about retrieval augmented generation. Sounds complicated, but it's really pretty simple. So LLMs are great at generating general content, but LLMs are really bad at generating up-to-date, specialized, and verifiable information. So let's talk about retrieval augmented generation. It's exactly like it sounds. You retrieve information from a trusted knowledge base or a trusted tool. You insert that retrieved information into the model's context, and then you generate an answer using in-context information. So Almanac, which was published inside of the New England Journal of Medicine AI in January 2024, was actually the first AI model to use RAG for medicine. We actually published our preprint a year before, but it took some time to refine the model. And without kind of drowning you in the details, what we did is we had our model retrieve information from PubMed, from UpToDate, from MDCalc. We have great friends there. And given any question, we tested on 300 medical questions across 8 different medical specialties. Our LLM was able to answer those questions and provide the source. So if you've used tools like Pathways, Open Evidence, you can kind of see where they got the idea from, hint, hint. Next, let's talk about the model context protocol. So we've shown you how to develop the tools and what you can use to develop the tools for AI models. But let's talk about how to actually make the LLM use those tools. So Almanac was a bit early. There was no standard protocol to using tools. You kind of had to define the tools manually. As of a few months ago, some great people at Anthropic developed what's called MCP, or the Model Context Protocol, which is a standardized protocol to provide LLMs with the ability to use tools. What's really cool about it is you're not stuck with one LLM provider. You can use any LLM and just switch out the name. So you can use OpenAI, Hugging Face models, any open source model, Anthropic, et cetera. And it's really easy to use. To use any set of tools that are available to you, or what we call MCP servers, you just specify the address and you're good to go. So it's really plug and play with a growing number of MCP servers. And it's really easy to understand if you have a traditional software background because it follows a client-server architecture. I promised I wasn't going to throw technical jargon at you. This is an exception. It's only 4 words you need to know. MCP hosts, which is the program that wants to use these tools. The MCP client is a subcomponent of the host that is able to access these tools. The MCP server is the actual tool itself, and the remote servers are the tools that the MCP servers actually makes use of. It sounds complicated, but this is really what it looks like. So you have an MCP client that's able to access different servers, and each server has access to its own database, its own tools. And to show you how easy this is to use, I actually went ahead and created 2 MCP servers for this competition, which you can use kind of remix for yourself. I downloaded the entire clinical trials database, embedded the brief description column. If you're not familiar with embedding, we can talk about that later, but it makes it easy for you to ask a natural language question and get that answer using natural language again, not simple string searching. And using a single line of code, you can actually convert that to an MCP server, and this is how Hugging Face makes that easy for you. And this is hosted publicly on Hugging Face. You can go access it. The link is at the end of this presentation. Similarly, I did the same thing for PubMed Medline, downloaded all of the articles, embedded the description, the abstract of each article, created an MCP component out of it, a Grado demo, so it's easy for you to kind of go on this website, ask any simple question, you'll get the resources directly from PubMed and clinical trials. All right, so now that you know about MCP and RAG, we can talk about AI agents. If you've hung out with any tech bro at the moment or any VC, I'm sure you've heard about AI agents. It's really easy. It's an MCP client and a while loop, which is really, really simple. I know it sounds fancy. So you specify an MCP server as the tools that you want to use. You specify the LLM model you want to use and just loop over it. Ask a question and loop, loop, loop. There you have it. That's your AI agent. To kind of make it easy for you guys to see what this looks like, I use Gradio to get the chatbot-like feel that you see on ChatGPT, Claude, etc. And if you take out the MCP client boilerplate code, it's only about 50 lines of code. And there you have it. So at the top, I specified the server where I think my vision isn't that great. I can't see if it's the PubMed MCP server or not. There's a big connect button, so you can connect that server. You can make that implicit or explicit, depending on how you're developing your application. And then you ask it a question, and there you have it. You have the model answering the question. You can tell it's using one of the tools I specified to answer the question and give you the source. So there you have it, your AI agent. You can now make millions of dollars and save patients. So let's talk about constraint generation. So as you know, LLMs are good at giving you answers to your questions, but we expect your answer to be formatted in a certain way so we can evaluate them well. Well, here comes constraint generation. So we expect a certain format. LLMs are really bad at kind of following the rules. So there are several ways you can kind of get it to give you the JSON format. So you can either prompt it. You can start with that. It's the easiest way to get started, but you won't get far. You can trust me or try it yourself. You can fine-tune the model to generate JSON. Again, it'll be good, but not great. And the current state-of-the-art approach is something called constraint generation. I'm not going to go into detail. You can find me later. We can talk about it in depth. But there are several methods to do so. You don't have to do it yourself. That's the great news. We have several open libraries to do it. You can use several different approaches: context-free grammar, regular expression, and finite state machines. And what you're basically doing is constraining the LLM to only sample from a select number of tokens based on what it's generated so far. And again, there are several awesome libraries out there that you can use for this. So you have outlines and JSON Former. I'm not affiliated. I wish I was. And here are the additional resources if you want to look at any of the resources I talked about. So we have Hugging Face, Almanac, MCPs in general, building MCPs with Gradio, clinical trials MCP, PubMed, Medline MCP, outlines, and JSON Former. Thank you very much. These are my socials. Good luck, everyone.